Assalamu alaikum wa rahmatullah. Hello everyone. In this video we will be looking at question 5 from the coverage of a grade 11 elite for term 2. So we have this question that says let f be a function that is everywhere differentiable and that has the following properties 1, 2 and 3. Part A says find the value of f of 0. So we are given that f of x plus h equals f of x plus f of h over f of minus x plus f of minus h. This is for all real numbers h and x. So h and x, they can be any real number, right? So part A, we need to find f of 0. So let's get started. We need to find, in part A, we need to find f of 0. So if you look at the function, you have f of x plus h equals f of x plus f of h all over f of minus x plus f of minus h. So we are looking for f of 0. So how do we make the x plus h 0 here? So we will let x equal 0 and h equals 0. So in this case, we will have let x equals 0 and h equals 0. So we will get f of 0 plus 0, right, equals f of 0 plus f of 0 all over f of 0 plus, there is no minus 0, right? So this is f of 0 plus f of 0. So f of 0 plus 0 will be f of 0, right? And the whole numerator cancels with the denominator. We get 1. So f of 0 equals 1. This is the first part. So part B says show that f of minus x equals 1 over f of x for all real numbers x. So in this part, we need to show that for part B, let me give myself a space. For part B, we need to show that f of minus x equals 1 over f of x, right? So this is what we need to get at the end. So we need to show that f of minus x equals 1 over f of x. Now, going back to the same function, so we need to get rid of h by letting h equals 0. So let h equals 0 for part B. What happens if we let h equals 0? We will go back to the function, the given function, which is f of x plus h. It becomes f of x plus 0 equals f of x plus f of 0 all over f of minus x plus f of 0, right? Now, f of x plus h, it's just f of x, right, equals, this is f of x plus f of 0 is equal to 1 from the first part here. We can just put 1 here, and this is f of minus x plus 1. So now you need to isolate f of minus x. How do we isolate f of minus x? So we will make the denominator here by 1, and then we will use the cross multiplication. So you have f of x multiplied by f of minus x. So we write f of x times f of minus x and then a plus. You have f of x multiplied by 1, which is f of x, right? Equals 1 times f of x, it's f of x. And then you have 1 times 1, which is 1. So we need to isolate f of minus x. So we will divide the whole equation by f of x. So in this case, what do? We divide by f of x, because our goal is to isolate this. This is what we need to isolate, right? We need to keep it alone. So we will divide here by f of x as well. You will divide here by f of x. You will divide here by f of x. So if we do this, what do we get? We get these two will cancel, these two will cancel, these two will cancel, right? So we've got f of minus x plus 1, f of x over f of x is 1, equals 1 plus 1 over f of x. We cancel the 1 and the 1 from both sides, so we end up having f of minus x equals 1 over f of x, and this is what the question is asking us to do. F of minus x equals 1 over f of x. Let's go to part C. Part C says, using part B, show that f of x plus h equals f of x times f of h. So this is what we need to show in part C. Show that f of x, let's do it here. We need to show that this is part C. We need to show that f of x plus h equals f of x times f of h. Let me just have a second look. Yes, f of x times f of h. So, we will go back to the given function in the question, which is we have f of x plus h equals f of x plus f of h all over f of minus x plus f of minus h. Now it says using the concept, or using what you got in part B, using part B, that means we can replace f of minus x here and f of minus h as well. So we get f of x plus h, right, equals f of x plus this is h, right? So f of x plus f of h divided by 1 over f of x from part B, and this is 1 over f of h also from part B. So what do we do now? Now we will simplify. So how do we simplify? Let's make the denominators the same. So let's multiply here by f of, not this one. So let's multiply here by f of x, and here by f of x, and here by f of h, and here by f of h. So this is what f of x plus h, it becomes what? Okay, it becomes f of x plus f of h. This is the numerator, remains the same for now. This is f of h, right, over f of h times f of x plus this is f of x over f of h times f of x. Okay, we can now simplify further. This is f of x. 1 second. So, f of x plus f of h all over, this is f of h plus f of x all over f of h f of x. So, we can now cross f of x plus h with f of x plus h. What is remaining if we do so? If we do so, we have f of x plus h equals 1 over f of x times f of h. So, why did I write 1 and 1? Because again, I cancel this f of x plus h. So when you cancel this one, f of x plus h, and this is f of h plus f of x, there is 1, right? Now 1 over f of x plus h, that means you just need to flip the denominator. It becomes f of x plus f of x times f of h over 1. That means this is, we have you have f of x plus h equals f of x times f of h. So this is what the question is asking us to do. Because 1 over f of x plus h, this jumps here. So it becomes f of x times f of h. This is part C. This is what the question is asking us to do. So the last part in this question says use the definition of the derivative to find f of x, f prime of x. So this is f prime of x in terms of f of x, in terms of f of x. So let's do part D here, okay? So we will start by writing what? By writing the limit definition of the derivative. F prime of x equals the limit as h approaches 0. This is f of x plus h minus f of x all over h. This is the limit definition of the derivative. Now, this part here, we did it in part what? In part C. So this is from part C, which is here, right? So if we take it from part C, what do we get? So we get that f prime of x equals the limit as h approaches 0 of, instead of f of x plus h, we will write f of x, f of h, okay, minus f of x all over h. So we can now factor out f of x because I can see it here and here, so we can factor it out. So what do? We write the limit as h approaches 0. We've got f of x, we've got f of h, right, minus 1 all over what? All over h. So we just factored out what? We factored out f of x. Now f of x has nothing to do with the limit. Why? Because the limit has h as its variable. So h approaches 0. So this f of x, we can just write it outside the limit. Yani, we can write f prime of x equals f of x, right, times the limit of f of h minus 1 over h as h approaches 0. So what does this limit represent? This one. This limit, what does it represent? Okay, let's do something here and then we'll come back to this limit. We know that f prime of 0 equals what? Equals to the limit as h approaches 0 of f of 0 plus h, right, minus f of 0 all over h. This is again the formal definition of the derivative, but at x equals 0. Now we can simplify a little bit by saying that f prime of 0 equals to the limit. What is this f of 0 plus h? It's f of h minus f of 0. F of 0, it's 1. We found it in part A over h as h approaches 0. And I can see it here. This business here matches this one, right? And it's equal to what? It's equal to f prime of 0. This one here. It's equal to f prime of 0. And f prime of 0, I think it's given in the question. F prime of 0, it's equal to minus 1 here. This one. So this is equal to negative 1. So we can replace it with negative 1. The whole limit is replaced with negative 1. So you've got f prime of x equals f of x times negative 1, which is minus f of x. This is the f prime of x as a function of x. It's f of negative f of x. So this one here, it's equal to negative 1. I hope that was clear. I wish you all the best. Good luck.